let's look at number 2. Here we're asked to do some polynomial long division, or polynomial division, I should say. And you can use either long division or you can use synthetic division. Totally up to you. I'm going to opt for synthetic division. So I look for what zeroes out the denominator, and I put that in that little house type symbol, like in the little half of a square here. And then I use the coefficients in front of my numerator to write, or that's what I write along this top row. Something to note though is I skipped over the x term, right? I went from x squared to 7, so there were 0 x's in this particular numerator, and I just have to represent that 0 when I perform synthetic division. That's the way to make this work. So I'm going to have my lead coefficient of 1, then negative 1 x squared. I had 0 x's and my constant was 7. And let's just see how this works. So again, drop the 1 down. I add up and down and I multiply across, right? So negative 2 times 1 is going to give me negative 2. Negative 1 minus 2 is negative 3. Negative 2 times negative 3 is 6. 0 plus 6 is 6. Negative 2 times 6 is negative 12. So that makes my remainder, 7 minus 12, negative 5. And how we work synthetic division is whatever degree we started with, which was a cubed term, this is now the coefficient 1 degree less. So what I mean by that, x squared, if I take that down a notch, x cubed. If I take that down a notch, becomes x squared. The coefficient is 1. So then minus 3x plus 6, right? And then I have this remainder of minus 5 over my divisor of x plus 2. So let's see where that matches up. So we got x squareds in all of the first positions. Can't eliminate anything there. Minus 3x is going to get rid of this answer and this answer. So it's neither A nor D. Then we have plus 6. That ties here. And when I look at my remainder was minus 5. So that gets me to option C. All right. Thanks so much. Bye.